Don't worry folks, our sun is a pretty chill star. It's not the type to throw tantrums or cause cosmic chaos. It's not going to explode anytime soon. In fact, it's got billions of years left in its life cycle. Right now, it's busy fusing hydrogen into helium, providing us with the light and warmth we need to survive. But some stars out there aren't so stable. They are the wild ones of the cosmos. These stars live fast and die young, burning through their fuel at an incredible rate and going out with a bang. We call these explosions supernovae, and they are truly spectacular events. Imagine a star shining as bright as an entire galaxy for a brief moment. Imagine the entire energy output of a star released in just a few seconds. It's a cosmic fireworks show like no other. Now what if a star exploded near Earth? Don't panic just yet. The chances are extremely low. Near is a relative term in space. Even stars that seem close are incredibly far away. Our galaxy is vast, and the odds of a nearby supernova are astronomically small. We're talking millions of light years. But let's imagine, just for fun, what would happen if a star in our cosmic neighborhood decided to put on a dazzling and potentially dangerous show? The effects would be both awe-inspiring and terrifying. Supernovae are some of the most powerful events in the universe. These colossal explosions mark the end of a star's life cycle and can be seen across vast distances in space. They can outshine entire galaxies for a brief period, making them one of the most luminous events known to humanity. Imagine billions of stars worth of light packed into a single explosion. The sheer brightness is almost unimaginable. That's a supernova for you. These events are not just visually stunning but also incredibly important for the cosmos. These cosmic fireworks happen when a star runs out of fuel and can no longer support its own weight. The star's core collapses under gravity. The core collapses, triggering a massive explosion that blasts the star's outer layers into space. This process releases an enormous amount of energy. The energy released in a supernova is mind-boggling. It's equivalent to the energy our sun will produce over its entire 10 billion-year lifetime, all released in just a few seconds. It's more energy than our sun will produce in its entire lifetime. This energy is emitted across the electromagnetic spectrum. This energy is emitted across the electromagnetic spectrum from radio waves to gamma rays. Each type of radiation provides valuable information about the supernova. If a supernova were to occur close enough to Earth, it would be a sight to behold, but it could also have some serious consequences. The radiation could affect our planet's atmosphere and potentially harm life on Earth. Throughout history, humans have witnessed these stellar explosions, recording them in their chronicles. One such event was the appearance of a new star in 1604, now known as Kepler's supernova. Johannes Kepler, the famous astronomer, studied this supernova extensively, marveling at its brightness. For weeks, Kepler's supernova was visible in the daytime sky, outshining every star except the sun. It was a celestial spectacle that captivated the world. Observations like these helped astronomers understand that the heavens were not unchanging, as previously believed, but rather a dynamic and evolving arena. Stellar evolution, from baby star to supernova. Stars like us have a life cycle. They're born, they live, and they die. Their death, however, can be far more dramatic than ours. Stars form from collapsing clouds of gas and dust. Gravity pulls the material together, increasing the density and temperature at the core. Eventually, the core gets so hot and dense that nuclear fusion begins. This fusion process, where hydrogen atoms combine to form helium, releases enormous amounts of energy, powering the star for millions or even billions of years, but eventually the star runs out of fuel. What happens next depends on the star's mass. Massive stars go out with a bang, a supernova, leaving behind either a neutron star or a black hole. Supernovae and Earth, a love-hate relationship? So, back to our original question, what if a star exploded near Earth? Well, it depends on how near we're talking. A supernova within a few light years of Earth would be catastrophic. The intense radiation would strip away our atmosphere, leaving us exposed to the harsh vacuum of space. Not a good day at the beach. Even a supernova farther away could disrupt our planet's delicate balance. The gamma rays could damage the ozone layer, leaving us vulnerable to harmful ultraviolet radiation from the sun. Life on Earth is remarkably resilient, but a nearby supernova would be a formidable challenge. Ghostly particles and energetic rays, the unseen aftermath. Supernovae don't just release light and heat, they also unleash a torrent of subatomic particles called neutrinos, and high-energy radiation known as cosmic rays. Neutrinos are like ghostly particles that can pass through almost anything, including our planet. Cosmic rays, on the other hand, are charged particles that can interact with Earth's atmosphere. While neutrinos are generally harmless, a nearby supernova would bombard us with an intense burst of these particles. Cosmic rays, while less intense, could still pose a threat to astronauts and even people flying in airplanes. They can also create showers of secondary particles in the atmosphere, potentially disrupting our electronics and communication systems. The cosmic perspective: rare events, big impacts. The good news is that supernovae close enough to harm Earth are incredibly rare. These colossal explosions, while immensely powerful, are not frequent visitors to our cosmic neighborhood. Astronomers estimate that a supernova occurs within our galaxy only once every few hundred years, making them rare celestial events that are eagerly anticipated by the scientific community. The odds of one happening close enough to pose a serious threat to life on Earth are even smaller, providing us with a sense of cosmic security. But while supernovae are rare events on a human timescale, occurring perhaps once in a lifetime, they play a crucial role in the grand scheme of the universe. These stellar explosions are essential for the evolution of the universe, acting as cosmic forges that create and distribute heavy elements. They seed interstellar space with heavy elements such as iron, gold, and uranium, the very building blocks of planets and life itself. Without supernovae, the universe would lack the diversity of elements needed for complex chemistry and biology. So, the next time you look up at the night sky, take a moment to appreciate the vastness and complexity of the cosmos. Remember that those twinkling stars are not just points of light, but ancient beacons of history and future potential, active participants in a grand cosmic dance, a dance that has been ongoing for billions of years, a dance that includes both creation and destruction, the birth of stars and their eventual explosive deaths, and ultimately, the potential for life itself. This cosmic cycle of life and death is what makes our universe so dynamic and full of possibilities.